I have spent my life thinking about questions most people are afraid to ask. Questions that stretch the human mind to its limits, and among all of them, none is more dangerous, more seductive, or more misunderstood than the idea of what lies inside a black hole. Because a black hole is not merely an object in space, it is a wound in reality itself, a place where the known laws of physics collapse under their own weight, where time slows to a standstill, space folds inward, and the universe confronts its own contradictions. And for decades, scientists believed that black holes were cosmic prisons, eternal graves where matter, energy, and information vanished forever, erased from existence as if they had never been. But this belief, though elegant, carried a terrible implication, because if information could be destroyed, then the universe itself would be unpredictable, its past unknowable, its future uncertain, and science, at its core, would fail. And this was the danger I could not ignore, because physics is built on the idea that the universe keeps records, that every cause leaves a trace, that nothing truly disappears, and yet black holes seem to mock this principle with silent arrogance, swallowing stars, light, and time itself, without explanation. And so I asked a question that many believed was foolish or even heretical. What if black holes are not perfectly black? What if they are not eternal? What if they leak slowly and quietly like embers cooling in the dark? And from this question emerged an idea that would haunt physics for generations, an idea now known as Hawking radiation, which tells us that black holes are not completely isolated from the universe, that at the edge of a black hole, at the event horizon where escape seems impossible, quantum effects allow particles to flicker into existence, pairs of energy born from the vacuum itself, and sometimes one particle falls inward while the other escapes, carrying energy away, causing the black hole to lose mass, to shrink, to age, and eventually, after unimaginable spans of time, to disappear, not with a scream but with a whisper. And this revelation was dangerous not because it destroyed black holes, but because it threatened certainty. Because if black holes evaporate, then we must ask what happens to the information they consumed, whether the universe forgets, or whether it remembers in ways we do not yet understand. And this question fractured physics into opposing camps, each clinging to different visions of reality, some arguing that information is lost forever, others insisting it must survive, hidden in subtle correlations within the radiation itself, encoded like a cosmic message written in a language we have not yet learned to read. And as I followed this trail deeper, I realized that black holes are not merely endpoints. They are laboratories where gravity, quantum mechanics, and time collide, revealing cracks in our understanding of reality. Because inside a black hole, the roles of space and time may reverse, turning motion into destiny, where moving forward in time becomes as unavoidable as falling toward the center. And at the singularity, the equations predict infinity, a word that signals not truth but ignorance, a sign that our theories have reached their breaking point. And this is why the idea of what lies inside a black hole is so dangerous, because it forces us to confront the possibility that reality is not smooth, not continuous, not even fully deterministic, but stitched together by probabilities, horizons, and hidden dimensions. And yet, despite its terror, the black hole is also a teacher, reminding us that the universe is under no obligation to make sense to human intuition, that simplicity is earned, not assumed, and that progress often begins by questioning what everyone else accepts. And so when people ask whether falling into a black hole would mean the end, I tell them that the true danger is not destruction, but ignorance, because black holes challenge us to unify the forces of nature, to reconcile gravity with quantum mechanics, to understand whether time has a beginning and an end, and whether the universe itself emerged from conditions not unlike a black hole, compressed, dense, and governed by laws we are still struggling to articulate. And in this way, black holes are mirrors, reflecting our deepest questions back at us, asking whether reality is fundamentally knowable, whether information is eternal, and whether the universe, like a book, can ever be fully read. And though I may not live to see these answers, I am confident of one thing, that curiosity is stronger than fear, that human intellect, though limited, is relentless, and that by daring to explore the most dangerous ideas, we move closer not only to understanding the universe, but to understanding ourselves. because the greatest threat has never been black holes, or the darkness inside them, but the willingness to stop asking questions when the answers become difficult. And yet, the deeper I traveled into this idea, the more I realized that the true mystery of black holes is not what they destroy, but what they preserve. Because if information truly escapes a black hole, even in the faintest and most distorted form, then the universe is not careless with its history. It is meticulous, patient, and subtle beyond imagination, encoding the past into patterns so delicate that only the most refined theories can hope to uncover them. And this realization changes everything, because it suggests that reality itself is not built on disappearance, but on transformation, where nothing is ever fully erased, only rewritten into forms that challenge our ability to observe and interpret. And this forces us to abandon the comforting idea that nature must behave in ways that are simple or intuitive, because black holes operate at the intersection of extremes, where gravity becomes absolute, time stretches toward infinity, and quantum uncertainty refuses to be ignored. And it is here, at this crossroads, that our current understanding falters, revealing that our most trusted theories are incomplete, powerful, yet fragile, capable of explaining much but not everything. And this incompleteness is not a failure, but an invitation, a signal that the universe still holds deeper layers waiting to be uncovered. And as I examined these layers, I began to suspect that the event horizon itself is not a passive boundary, not a simple point of no return, but an active participant in the story of reality, a surface where information is scrambled, stored, and slowly released, much like the memory of the universe spread across a shimmering cosmic screen. And this idea, that the surface of a black hole might contain all the information about what has fallen inside, suggests that the universe may be holographic in nature, that the three-dimensional world we experience could be encoded on two-dimensional boundaries, a notion that feels unsettling, yet strangely elegant, as if reality is far more economical than we ever imagined, conserving information with ruthless efficiency. And if this is true, then black holes are not anomalies, but keys, revealing how space itself may emerge from more fundamental principles, how geometry could be born from information, and how time might arise from relationships rather than absolute flow. And this leads to a profound implication, that what we perceive as the interior of a black hole may not exist in the way we imagine it, but rather as a mathematical description, a translation of information. Ions stored on the horizon into a form our equations can approximate, and this challenges the very meaning of inside and outside, suggesting that space is not a container, but a consequence, not a stage on which events unfold, but an outcome of deeper hidden processes. And when we follow this reasoning to its conclusion, we are forced to reconsider the origin of the universe itself, because if black holes encode information on their boundaries, then perhaps the early universe did the same, compressed into an unimaginably dense state, governed by horizons that shaped everything that followed. And this raises the possibility that the universe began not as a singular explosion, but as a transition, a change of phase, where information reorganized itself into space, time, and matter. And if so, then black holes are not cosmic dead ends, but echoes of the universe's own birth, reminders of conditions that once defined all of existence. And as unsettling as this idea may be, it carries a quiet optimism, because it suggests that the universe is fundamentally comprehensible, not in the sense that it is simple, but in the sense that it obeys principles that are consistent, logical, and discoverable, even if they lie far beyond our current reach. And it tells us that knowledge is not limited by darkness, only by patience, ingenuity, and the courage to challenge assumptions. And this is why I have always believed that the most dangerous ideas are also the most necessary ones, because they force us to abandon intellectual comfort and venture into uncertainty where real progress is made. And black holes, more than any other object in the cosmos, demand this courage because they expose the tension between determinism and chance, between continuity and discreteness, between what can be predicted and what can only be described statistically. And in doing so, they remind us that the universe is not obligated to conform to human expectations, but we are obligated to refine our understanding to meet its reality. And perhaps the most profound lesson black holes teach us is humility. The recognition that even our most successful theories are provisional, stepping stones rather than final answers. And yet this humility is not discouraging, it is liberating, because it means the story of discovery is not over, that there are still questions worth asking, still mysteries worth pursuing, and still truths waiting beyond the horizon of our current knowledge. And though we may never physically enter a black hole, we can approach its secrets through thought, mathematics, and imagination, extending our reach far beyond the limits of our senses. And in doing so, we affirm something deeply human, that curiosity does not fear the unknown. It is drawn to it because every mystery solved reveals not an ending but a new beginning. And so when we speak of black holes as dangerous, we must remember that the real danger has never been the collapse of stars or the warping of space and time, but the collapse of curiosity itself. The moment we decide that some questions are too difficult to ask, because it is only by confronting the darkness, by studying it, questioning it, and refusing to look away, that we bring light into our understanding. And in this pursuit, black holes cease to be symbols of destruction and become instead beacons of insight, guiding us toward a deeper, more unified vision of the universe, one where information is eternal, reality is richer than it appears, and the human mind, though small in scale, is capable of grasping truths written across the vastness of the cosmos.